Hello everyone, welcome to my YouTube channel. Today we are going to solve the today's problem of the day of Geeks for Geeks. The question name is range LCM queries. Question says that given an array ARR and the list of queries and each query can be one of the following two types: update query or range query. Update query means we are having three things: one, index and value. Update the elements at position index in the array to the given value. And range query having three things: to LR, that means compute and return the least common multiple LCM of all the elements the subarray from index L to R inclusive, and process all query sequentially and return the list containing the results of all type 2 queries. Okay, and we have to all operations allowed zero based indexing. So given examples and we have performed this query, then output would be this. So let's write the code for the same. We will use the segment tree approach. So first we will build the tree, then we will perform update query, then range query. For that I'm going to write the code in Python. So let's see. First we have to import the GCD, because for LCM we have to use GCD method. So from math I'm going to import GCD, and after that I will write the function for LCM, def LCM, that having parameter self, two numbers for a and b. I'm going to find the LCM of two numbers a and b, and we have LCM would be returned the product of a into b and divided with the GCD of a comma b. Okay, so that would be the LCM of two numbers, and then you have to process our query. So for that we will start n equal to the len of array ARR, and for every segment we will define self dot segment. We will define it, we will define it as a array of 1, and that is of size 4 into n, and then I'm going to define build. So self dot build, build, and that build has parameters. We will call it the function build, and the parameter with 1, 0 and -1, and passing the ARR array. Okay, and after that we will take one array answer equal to list, that will store all the outputs for both the queries, and then we are going to iterate throughout the queries. For q in queries, queries queries, first thing is we have to use update query. So write update query, and for update query we will check if q of 0, that means first part, is equal to 1, that means we have to update our query. So for that we have three parameters. First is 1, for that I'm going to not need to store, so just take underscore. Then second is index, third is value, then value this thing would be having in every query, that means q, and then we have to call the function self dot update. We will define that function later. Self dot update with pass with the parameter 1, 0 and -1, and index and value. So these things are we are passing as a parameter. The second query is range query, RERY, and we will check it, else if it is not 1 then would be 2. So for that I'm going to use store it again, L comma R equal to Q, because our range query has L comma R. Then we will append it to our answer dot append self dot range query. We are going to pass our range query or we can say range query query, and we are passing as 1 0 and -1 and L comma R. Okay, so these things we are passing as a parameter. After that we will just return answer. So that would be our driver code, and after that we have to define the functions, and we have to build segment tree. So first we are going to build the segment tree. Okay, so let's write the code for building segment tree. Definition of the function would be build. There we have parameters. First is self, next is node, then we have start and having end, and pass the array, and after that we will check the condition. If start equal to end, start is end, then we will update our self dot segment of node with array of start, okay, and here not need to do anything, just return, and then we will calculate mid. That would be equal to start plus end by 2, start plus end by 2. Then we will pass the function recursively, self dot build. We'll call the function by for the both left child and right child. And left node we are having 2 into node, and from starting to the mid we have to pass the array, and again we have to use for the right child. For that I'm going to use build 2 into node plus 1, 2 into node plus 1, and from mid plus 1 to the end of the array. Okay, and after that defining both, we have to update our segment of node. So we will update self dot segment of node. That would be updated with self dot LCM, self dot LCM of self dot segment of left value and node value. We are using the both the LCM of childs. So for that I'm using 2 into node for left child, and taking LCM of left child with the right child, and self dot segment of 2 into node plus 1, 2 into node plus 1. So in this way we are taking the LCM of both and updating our segment of node. Our segment of node having the LCM of its children, and then we have to write the function for update query. We have update, and we are passing the parameter as self comma node comma start comma end comma index and value val. These things we are passing as a parameter. After that we will checking again if start is equal to end. Then what we have to do, just nothing, we can uh, update our start node as a value, self dot segment of node, that would be equal to val, and return. And after that we will update our mid. So mid would be equal to start plus n by 2, start plus end by 2. Then we will check condition if index is less than equal to mid, index is less than equal to mid, the index is less than equal to mid, then we will update our we will call the function or recursively self dot update For left child and right child, we have to do, first we will write for left child node comma start, from starting to the mid, then pass the index and val again, and otherwise if it is not true, then for the else condition we will pass for the right child, then if it is not true, then self dot update, let's scroll it up, self dot update. For right child we are using 2 into node plus 1, 2 into node plus 1 comma start comma from mid plus 1, not start, from mid plus 1 to the end, we are passing index comma val, and after that we have update, we have completed our update function. Then we will again, we will write the segment of self dot segment, we will update for this particular node self dot segment, that would be updated with the LCM of our left and right. Okay, so just write the copy this, and we have to paste it again, control C, control V. So we are passing with the self dot LCM of segment node left node and the right node, that would be the LCM of left and right child. Okay, then we have another function def queries, or we can say range queries, so I can just use query, not range query. Def define it as a query, and for every query we have parameters like self, then array, and before it I have a node comma start, and we don't have array, we have left and right here, so we have start and end and left and right, so these things are as a parameter, and we will check if r is less than start, if our right thing is less than start, or end is less than l, or end is less than l. That is the base case that we can return just one, and after this we will check if our l is less than equal to start, our less than is equal to start, and is less than equal to r, less than equal to r, then what we have to do, we have to return our node self dot, we can return self dot segment of node, and after that what we do, we will update, we will find the mid again, that would be start plus end by 2, start plus end by 2, and then we will update, we will define our left and right. So define the left as self dot recursively call the function query, and for every query we have to call the, for the left we have to use left child 2 into node from, and start to the mid, and we have pass l comma r, and for right we will again call the same function self dot query, self dot query with the passing with the right child, that is 2 into node plus 1, 2 into node plus 1, and from mid plus 1 to the end, and we are passing l comma r again. Okay, so we have defined both left and right, and after defining we have to return the LCM of left and right, we will return the self dot LCM of left comma right. Okay, after defining this we have processed the query. For each query we have write the code. Let's try to run it. Control Z. Okay, so our AGST is right. So sorry, we have written a bracket here, so I have to remove it. Line number 38. Now try to run it. So because we are using a local method, so we not need to use self gain again, so we can just remove that selves. Okay, let me remove them. So remove the self here, and from here, and here also remove self. Okay. Now I have updated the remove all the selves from this code, and after that try to run it. Yeah, it is passed. Now try to submit that. Thank you for watching. Hope you understood that.